Okay, we're going to try to do solving equations with fractions, and we'll see how this goes. So if you have your hand out like this, I'm going to zoom in a bit when I write. So solving equations with fractions, there's different ways of writing algebraic fractions. So here's the first way, 3 over 2y. You know that that could also be written as 3y over 2. You could extend the fraction bar. If you're not sure why that's true, over here, if you have 3 over 2y, that's the same, whoopsie, 3 over 2y is the same as 3 over 2 times y. And y, if it was like a number like a 5, and you want to multiply it with another fraction, you put it over 1. And when you multiply two fractions, you know that you multiply the top two numbers to get 3y and the bottom two numbers to get that. So that's why it's true. So this is what I mean later on when I say extend the fraction bar to make everything fractions. You don't want to write it like this. You want it written like this. It'll make it easier. Okay, the next thing. Similarly, we can show that if you have a fraction multiplying with a bracket, you could simply multiply the tops of the fraction. You can kind of think of this here as over 1, and then it'd be 1 times that bracket would be the bracket, and 6 times 1 would be 6 on the bottom. So that's the first step when you have equations with fractions. We want everything to look good, and that's what we're going to do. When we see things that look like this, we're going to write them like that. When we see things that look like this, we're going to write them like that. And that's before we even get started to make it easier. So I've listed here the steps for writing, for solving equations with fractions, which I'll come back to. We'll just start in and then I'll refer back to them. One thing is what I already talked about is step 1, make everything fractions. In other words, put whole numbers over the number 1 and write fractions such as that, 5 over 7a, as 5a over 7, which we just talked about. The next part is, let's go and try this question. So we've got, in this case, you've done this before in grade 8 by getting common denominators and grouping the y's on one side and everything on the other. But we're going to do something new, and you're going to learn how to do this a different way, and this is the way you must do it. Okay, so even though there is another way to do it, we don't want you doing it that other way, because when you move past this unit onto something else, you won't be able to solve the future equations using your old way. You have to do it this way, so you must learn this and practice it. So this is called clearing the denominators. That's the technique we're going to use. So when you have these three fractions and an equal sign, you know you have an equation. When you have an equation, you can do the same thing to both sides and the equation is still true. So what we're going to do is we're going to think about, if I just had this fraction, if I multiplied that fraction by 2, the 2's would cancel. The 2 on the top would cancel with the 2 on the bottom. So that's how I would clear that denominator. The next one, though, I would need to multiply it by 3. If I can multiply it by 3, the 3's would cancel, disappear. And this one would need to be multiplied by 6. So what I'm going to do is I'm going to look at the three denominators, 2, 3, and 6, and think, what is the one number that all of these numbers go into? The smallest number. That's called the lowest common multiple, or the lowest common denominator if you were trying to add these fractions together. You'd be trying to get the number that is the lowest common denominator, but we don't want that. The number we're looking for is the same number as if we were doing that. So the one number all these numbers go into is 6. So you say, yes, I recognize that it's 6. And you're like, okay, I'm going to multiply both sides of this equation by 6. So I'm going to go like this. Sorry, I'm not very good with the camera. I'm going to go like that to show that I'm multiplying both sides by 6. And I'm going to show that I'm going to multiply both sides by 6. Now, when I multiply two things being added in a bracket, I distribute the 6 to both of them. So really what I'm going to do is write it like this. Okay, so that's what I've got. That's multiplying both sides by 6. And now I can see I can cancel off the 2, goes into itself once, into 6 3 times. 3 goes into itself once, and it goes into 6 twice. 6 goes into itself once, and it goes into 6 once. So now I'm left with all 1's on the bottom, So I have no more denominators really because I've got a 1. So that's what I've done. I've cleared the denominators in one fell swoop. Whoop, multiplying by 6 gets rid of them all. So now I have to just recognize that I have a leftover. I've got 3 times y. This is 3y. And I've got the 2 times this y. I got the equal sign, and I've got 5 times 1 is 5. So in one step, I got something really easy. So this combines to give 5y equals 5, and divide both sides. So I'm getting squishy here. Divide both sides by 5 will give me y is equal to 1. And that's the answer to that one. So that's the easiest example because you can see all the denominators and you can usually see that they all go into 6. Okay, the next example, 2x over 3 equals 3x over 4 plus 3. Again, step number 1, recognize you have an equation, and you know that because of the equal sign. So you're like, hey, I have an equation. There's fractions in there. Oh, but I only see 2 fractions, 1 here and 1 here. That's not a fraction. Make it 1. Put it over 1. Now I have all fractions. Then you look at the denominators, 3, 4, and 1. What's the one number that 3, 4, and 1 all go into? Well, unfortunately, we're going to have to do 3 times 4, and it's going to have to be 12. Unlike over here, where 2 and 3 both went into 6. Okay, we have to get something bigger. So 12 is the LCM. That's what I'm going to multiply both sides by. Now remember, when I multiply this side by 12, I can go like this. When I multiply this side by 12, I could put it in brackets and put the 12, but then the next step would be to distribute it to both. So instead, I'm just going to do that now. I'm going to put a little 12 here, and I'm going to put a little 12 there. Just saves me a step. Okay, so long as you understand that that is indeed multiplying both sides by 12. Okay, then I start canceling. Remember, if you pick this number right, once you do this step and cancel, there should be no fractions. So 3 goes into itself once and into 12 4 times. 4 goes into itself once and into 12 3 times. And unfortunately here, the 12 doesn't cancel with anything. Like the 1 doesn't cancel, you're just stuck with it. So over here, we're left with 4 times 2x on the top. So we're going to get 8x. And then we're going to have over here, remember that's a 1. Here we have a 3 times 3x is 9x. And we have 3 times 12, which is 36. Okay, so the next thing is we're going to group all the x's on one side and the numbers on the other. So it would be easiest to say leave the 8x there. We've got a 9x on this side. If we subtract 9x from this side, it will be gone. But we will also have to subtract it from this side. So here I'm not going to write it. 9x plus 36, take away 9x, because I'm just going to know that I'm going to subtract it away. Okay, and so then I'm going to get negative x is equal to 36. And so I have a choice. I can either divide both sides by -1 or multiply both sides by -1. Either way I do it, I end up getting x is equal to 36. And that's the end of that one. Now, over here. This one's a little bit easier because we have 2 fractions that are equal to each other, as opposed to over here where we had one fraction was equal to the addition of 2 terms, and here we had one fraction was equal to the addition of 2 terms. When you have just 2 fractions that are equal, you've learned to do this by cross multiplying, and that still works. But since we're trying to learn this new technique, I just want to stick with that one. Okay, but this is what cross multiplying really is. This is what you've been doing all along. So the denominator is 2 and 8. Lowest common multiple that they both go into is 8. So I recognize that's the number. So I'm going to multiply both sides by 8. If I multiply both sides by 8, obviously it cancels on that side. 2 goes into itself that once, and it goes into 8 4 times. And then I'm left with 12x is equal to 5x. And then I say, hey, what the heck? That makes no sense. 5x is equal to 12x is equal to 5x. No, it's not. Let's see. Let's subtract 12x, take away 5x is equal to 5x, take away 5x. And so 7x is equal to 0. Oh, divide both sides by 7 Hopefully you see the answer now without having to do all this. X is 0. That's a weird answer, but that's the answer. That's the only time that this would be true. So X is 0. Okay, over here. Again, we've got two fractions that are equal to each other, and so cross-multiplying will work, but we're learning our new technique, so we're going to try to stick with that. If the denominator is 6 and 2, the one number that will wipe them all out is a 6. So I'm going to multiply both sides by 6. And I'm going to cancel, 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 cancel. Sorry, it's getting squishy up here. Okay, so I canceled. 6 became 2, went into itself once and into 6 3 times. So now I'm left with on here, nothing's there, so it's like a 1. So I got x minus 2 is left on that side, equals, and over here I'm left with 3 times x plus 2. So I might like to write it like this instead, rather than putting the 3 on the end, just we're used to that more. Remember, denominators are all 1, so I don't need to write them. This 3 gets distributed through. And now I've got a linear equation that's quite nice. I can now just move the x's to one side and the numbers to the other. So since 3x is on this side, I got more of them, and there's an x on that side, I'm going to bring this x over there by subtracting it from both sides. So if I subtract an x from this side, it's gone. If I subtract an x from this side, I'm left with 2x. At the same time, I'm going to move this over here by subtracting 6 from both sides. If I subtract 6 from this side, it's gone. If I subtract 6 from this side, I get -2. Take away 6 is -8. Now, if you want to actually write that down and do it in 2 steps, you can. But if you're able to understand it, it's better to skip it if you get it, because then there's just less writing, less confusing. Okay, and then the last step, of course, is to divide both sides by 2 to get x is equal to -4. Okay, E. This one is a classic example of cross multiplication that you've done before. You've done this in grade 7 and grade 8, but you just never really knew why. It was just a trick you were taught, and you're like, okay, I accept it. It's a trick I was taught. When the variable is in the bottom, it's very tricky to see that the lowest common denominator is actually 3x. This denominator has a 3. This one has an x. We know to get a common denominator, you could just multiply the two together. So 3 times x is 3x, and that would work. If this is going to be a 3x, oh darn, I'm losing power. If this is going to be a 3x, I'd have to multiply the top by 3. And if I change that to 3x, I'd have to multiply the top by x. And that's how you would have done it in the past. But that's kind of confusing for someone in grade 9 with that number x being there. So the easiest thing to do would be to cross multiply. But notice, cross multiplying gives me 2x on one side, 2 times x, and it gives me 3 times 3, which is 9 on the other side. And then x would equal 9 over 2. But I'm trying to figure out where to write this. I'm going to write it over here. Okay, I'm just going to go to the side here. But notice 3 over x equals 2 over 3. I just said that the two together would be the LCM. LCM is 3x. If I multiply this side by 3x and I multiply that side by 3x, over here, the 3 portion is going to cancel away, just leaving the x. So I get 2x, 2 times x. On this side, just the x portion cancels away, leaving me 3 times 3 is 9. Voila! That is cross multiplying. It's just you've never had to cancel before. You never had to find the LCM and cancel it off. You just crisscrossed and got this answer. But what you were really doing was clearing denominators by finding the LCM. We just never made you do it before because it was kind of hard. And to get through a lot of problems that you had to have in the past, it was easier for teachers just to teach you this little trick until you could understand it better in grade 9, understand why it works. So it's not really a trick now that you know why it works. It's actually math is why it works, not a trick. So cross multiplying only works when there is one fraction on either side of the equal sign. Do not try to do this any other time. It won't work. Okay, So even though I've been teaching you to clear denominators by finding the LCM, in the case when you have two fractions equal to each other, you can go ahead and cross multiply. That's fine. I just want you to understand what you're really doing is clearing denominators. But of course, go ahead and do that. This one example, hey, we've got a fraction, subtract a fraction equals a number. We don't have one fraction equal to another, so there's no cross multiplying allowed here. We do have a whole number, -5. We don't like that, so we're going to put it over 1. Now we have all fractions, and we see the denominators, 3, 4, and 1. So the denominator, that if we were to add them all together, we would want denominators of 12. We're not going to get a denominator of 12. Instead, we're going to get rid of denominators. So the LCM is 12. I'm going to multiply both sides by 12. Okay, because this is the subtraction or addition of two fractions, that 12 is going to get distributed to both. So I'm going to write it out like that on the next step. Oh, I forgot to say something. I'll do it after. Now that subtraction sign, you may as well just leave out here instead of introducing extra signs. That would be confusing. Okay, so I've just shown that that 12 goes to both. Okay, so over here, I know that that is -60, so I may as well just go ahead and write that answer. Over here, there's going to be some canceling. 3 goes into itself once, and it goes into 12 4 times. 4 goes into itself once, and it goes into 12 3 times. So now, if you're able to skip the next step I write, go ahead, but this might help you. If you see that there's a 4 there, write the 4. And then you see up here, what's left is 2x minus 1. You want to make sure you write that in brackets because that entire numerator needs to be multiplying with that. The next thing is subtract, and that's a +3, so just leave it there. And x plus 2 is left. And all the ones, you don't need to write them. Whoops. And that's why I should never do it the way I did it. And then go in order, -60, just so that it lines up better. Okay, so if you can skip this step and you can just go distribute this 4 through the bracket and go to the next step, and distribute the 3 through the bracket and go to the next step, go ahead and do that. But otherwise, write this step in to help you see everything better. So we're going to distribute 4 times 2x is 8x, 4 times -1 is -4, -3 over there, -3x, -6, and -60. And we've got 8x and 3x that we're removing. So we've got 8 take away 3 is 5x. And we've got -4 and -6 combined. We got negative and then more negative is -10 equals -60. Please always do this step. Group all the x's together on one side, group all the numbers together on one side before you start moving stuff around. You usually make a mistake when you move things around. So to make that less likely to make a mistake, do everything you can on one side first so you have less stuff to move. Now you'll see we just have this -10 to move to that side, and the way we move it is we add a 10 to both sides. Adding a 10 to this side would -10 plus 10, it would be gone, and leaving us 5x. And adding a 10 to this side would be -50. Then I can divide both sides by 5 and get x is equal to -10. Okay, very similar to what we did before. So one thing I didn't say that you'll see that are in the instructions that I should have done on the last one, but I'll do it now. Okay, we've got, I'm going to show you in a second. So we've got a fraction plus a number equals a fraction plus a number. So let's get those numbers over ones, or sorry, over something. Oh, that was a fraction, sorry. So we're going to put that over 1, and we're going to take numerators and we're going to group them together by putting brackets around them. That just helps make sure we hold on to them. And go ahead and do it around the single numbers too. It won't ever hurt you. So that's a step that I say that just makes things easier. So our denominators 3, 4, and 2. 12 is the LCM. You're going to see that the numbers are always kind of similar because we don't want to give you disgusting numbers for LCM. So they're going to turn out to be numbers like this. So I'm multiplying both sides by 12. Even though I'm writing down 12 several times, remember if I multiply this side by 12, the 12 would distribute to both terms. And if I multiply this side by 12, the 12 would distribute to both terms. So I'm just skipping that step. but I don't want you to think I'm doing something fancy. I'm still just using the rule that whatever you do to one side, you do to the other. You can't do things to parts of a side. Okay, so I've distributed the 12, and now I'm going to look. 3 goes into itself once. We're getting kind of used to this. 4 goes into itself once, into 12, 3. 2 goes into itself once, and into 12, 6. So again, here's the step that if it helps you, if you find this confusing to look at, you can write this next step. Otherwise, you can skip it. I'm not going to write 6 times 1. I'll just write 6. Okay, so now I have to distribute. This is why we put brackets around the top of the fraction at the beginning, is so that when we did all this, we didn't mess this up. That entire numerator has to get multiplied by the 4. So if we put it in brackets at the beginning, it helps to avoid making any mistakes in questions later. So we're going to distribute, and we're going to get 20x plus 8 plus 24, 6x subtract 9 plus 6. And again, tempting to maybe start moving stuff around. Do not do that. Group on this side anything together that are like terms. So 20x, 32. And on this side, 6x subtract 3. Now that you can't simplify either side anymore, now's the time to start moving stuff. I see I've got 20x here and 6x there. I've got more on this side. I'm going to leave it over here. So on this side, I'm going to have 20x take away 6x. I also subtracted 6x from that side, but of course it would disappear. That would leave me -3. And I'm going to subtract 32 from both sides. I'm just combining it, doing it at the same time. Okay, and then that would leave me with 14x. And on this side, did I have that right? Yes, -35. And then, now we've been here before, at the end where you're just dividing off the coefficient of x. And I know that 7 goes into 35 5 times. So I'm dividing both by 7. 7 goes into 35 5 times, so -5. And 7 goes into 14 twice. So I've just reduced the fraction. So you can get fractions for answers. So far I've given you all nice numbers, but this can happen. And it's perfectly fine. Okay, power through, last one. This one already has some brackets for you, but this is something that I showed you at the very beginning. We have a fraction times a bracket equals a fraction times a bracket. So you can do this kind of 2 ways, but I had said just imagine this being over 1. You'd multiply the tops together and the bottoms together. So I like to just kind of take this fraction bar and extend it. Take the fraction bar and extend it. So what I really have is -1 times 3 minus 5x all over 6 equals 2 times 5x plus 3 all over 3. Okay, now I can distribute that negative through the top, that -1, to get -3 plus 5x on the top. And if I distribute this one over, I get 10x plus 6 over 3. And now I have my 2 fractions that are equal, but I'm going to clear denominators or cross multiply. If I cross multiplied, I'd be multiplying, actually by a much bigger number, 18. So rather than make the numbers big, it is better just to multiply both sides by 6, because that's going to get rid of fractions, which is what we're trying to do when we cross multiply anyway, is to get rid of fractions. So this way we just have smaller numbers. So we're going to see that 6 is the one magic number that's going to eliminate everything. So remember I said group numerators together in brackets to hold them together. Multiply that side by 6 and this side by 6. I'm going to speed it up a bit. The 6's will cancel. Over here, 3 into itself once, into 6 twice. And that leaves us just with -3 plus 5x on that side. And here we have to distribute the 2 to both of those. So I'm going to get 20x plus 12. And because 20x is bigger, I'm going to leave the 20x where it is. I'm going to bring the 5x over by subtracting it from both sides. I'm going to leave the minus 3 where it is, and I'm going to get rid of the 12 from this side by subtracting it from both sides. So we get minus 15 on this side, and I got 20x, take away 5x is 15x. Divide both sides by 15. I was nice to you here, gave you a nice answer. And that's solving equations involving fractions. So when we go back to this explanation of the steps, I've said make everything fractions. In other words, put whole numbers over 1 and write fractions such as this as that. If the numerator, top, consists of more than one number, put them in brackets. So that's like here. The numerator was like 5x plus 2, so I said put those in brackets. Find the LCM of both sides. So what would be the number that all the denominators in your entire question can go into? You're going to remove that. Hang on. Oh, I've said that wrong. Remove the denominators, that should say. I'm not writing it very well. That word should say remove the denominators by multiplying both sides by the LCM. That's going to cancel all denominators away, and then you continue solving as you would any other equation. Okay, this at first may seem hard, and it is, but once you get it, it's way, way easier than doing it any other way. So plow through, practice, don't skip ahead to stuff like this too soon. Excuse me, until you've mastered, all of these ones first. Okay, good luck. That is solving equations with fractions. This is a key concept that is introduced in grade 9. It is guaranteed on your exam. This is a very important thing we want you to know how to do. So give it some good time. That's 27 minutes. Bye.